we are going to have a presentation at the beginning of the afternoon from many users coming from different sectors. So I'm going to start with a general presentation talking about what we've been doing for the Copernicus Marine Service in order to increase the user engagement and uptake. And then we are going to leave the floor to the users of the Copernicus Marine Service. So we are very happy to have Ken Fujiwara who is the CEO of the Umitron company in Japan, who is going to tell us about how he's using the data for aquaculture sector. Then we are going to have Nathaniel Bensoussan, who is an independent oceanographer working with Mr. Garabou for TMedNet. Then we are going to have a presentation from Henrik Ramm-Schmidt from the NauticAI Finnish private company, who's going to tell us about the use of the data for the shipping sector. Then we are going to have Matthias Delpey, who is in charge of research and innovation activities at the Sea and Water Environment Division of the SUEZ Group, who is going to be telling us about a project which is called FML-TRACK, who's dealing with marine litter. Emma Reyes is going to take over. She's the high frequency radar specialist at SOCIB, and she was also in charge of the IBISAR project. So she's going to tell us about this IBISAR project dealing with security and safety at sea. And last but not least, Renaud Laborbe from Artelia Digital Solution, who is a director, a project director. He's going to tell us about the Wax Coast project. And then we are going to have a question and answer session. And then we are going to have a roundtable with discussion between a dialogue between some of the Copernicus Marine data providers and some of the users. And we will introduce all the participants with Jan Drillet, my colleague. So we are both going to be animating this roundtable. And then we are going to break for 1.5 hours for an interactive session. And then we are going to be resuming with one short presentation about sea turtles and a roundtable about the EU policies and EC perspective. So this is it for the agenda. So now let me share my presentation. Can you see? Okay, can you see my presentation now?
Yes.
Okay, thank you. So I would like to tell you about what we did for the last 5 to 6 years in terms of user uptake and engagement for the time period 2015-2021. So the objectives we had were to increase the uptake by new users from new communities and to, of course, also increase the satisfaction and loyalty of the existing users. For this, we've been using many instruments, and I'm going to give you an example of some of the instruments we've been using to achieve those objectives. We've been, of course, organizing events and training workshops. We've been organizing partnerships, organizing user uptake call for tender. We've done also marketing and communication campaigns. We've been showcasing the offer and the data usage, and we've also been gathering the user feedbacks. So those are the numbers of the uptake during the user uptake during the 5 years time period from 2015 to 2020. So we have now more than 28,000 subscribers, and it's 6 times more users than we had at the beginning. So we had quite a huge uptake from the users, and we also have more active users and more regular users as well. So during those 5 years, we really went from a science market to a service which is now dedicated to society at large. We've been developing a lot of documentation and information for all the market sector, coming from the environment, the societal, and the economical markets. And all along from 2015 up to 2020, we've been organizing many events dedicated to new communities. And those are 3 examples, but there are many more. We've been doing a workshop for the outermost regions, for example, that was in 2019. This same year, we did a workshop as well for the aquaculture sector, together with the ETIP partners. So each time we've been organizing new workshop for new communities, we've been really partnering with the people that have the network, and ETIP is one of them, for example, for the aquaculture. We've also organized a workshop at the end of 2019 for the member states and the policy stakeholders dedicated to the Marine Strategy Framework Directive. So those are a few examples of events and dedicated events we've been organizing for new communities. Our service also went from a scientific drive to a policy priority steering. Meaning that our service has been used and showcased within many reports, including the IUCN reports, some of the WMO Global Climate Change report, and the IPCC reports, for example. And we are very, very lucky to have users who are ready to commit and provide with feedback. So we went from a targeted user to a real user and committing feedback user community. We've been gathering since 2011 many user feedback which are fed back into the offer. So we are really trying to have a user-driven service offer and product offer. So since July 2011, we've been gathering all the feedbacks coming from many channels, like from the service desk, for example, from questionnaires, from all the workshops we had, and from a group that was created in 2019, which we call the Champion User Advisory Group. So we have been analyzing all those feedbacks within 6 topics of feedbacks, including what kind of additional product or new products are needed, or what is needed in order to better access the data and the products. Overall, you can note that the user satisfaction has been quite stable all along the time period, with a mark of 4.7 out of 5. Here are more detailed user feedbacks. Actually, those are the top 10 user requirements. The blue one are from the general users, and the bottom one are coming from our Champion User Advisory Group, but more or less they really converge, meaning that globally users are willing to have higher resolution products in general, and more particular at the coast, with a fit for purpose parameter needed at the coast. They are willing to be able to search, choose, and access the data more easily. I mean, a non-experienced user should be able to come to our catalog and choose the product. And also, they are also willing to download more easily very large volumes of data. They are also willing to access the data which is under a netcddf format under new formats. So they would like that there is an easy conversion to other formats using professional APIs or plugins, for example, or other software like the AirDAP and OpenDAP that we heard about this morning. And from our champion user group, we had the following feedbacks, which are really converging with the one I'm listing on top, which are to facilitate access to the data through professional APIs, search functionality, a better scientific accuracy as well. We also need to facilitate the understanding of the offer, which is sometimes very hard to dive into because there are so many products in the catalog. And of course, we need to keep a dynamic product and service offer. We need to provide higher resolution products. And we also need to provide what is written here like brown products, but it's coastal products in general. So another instrument we've been using in order to increase the user uptake is what we call the User Uptake program. So it's a program that went for the last 5 years, which has been launching call for tenders, or there has been 6 call for tenders in total, and 40 contracts have been selected, and all those contracts have been developing demonstration, concrete demonstration of the use of the Copernicus Marine Service data. So it's gathering innovative consortia coming from 46 different organizations and 18 countries, 60% from the private sector, 40% from the public sector. All the demonstrations which have been developed are showcasing the use of the data within all the European basins from the Copernicus Marine Service, but also for the global ocean and for some of the market sector, like the polar environment monitoring, for example, and the safety and disaster. And we are going to have testimony from the users just after actually going into more details of some of those projects. So for us, those contracts have been showcasing how the Copernicus Marine products are useful. They have allowed the development of downstream services within EU member states. And they have shown how Copernicus Marine can contribute to EU directives such as the Maritime Strategy Framework Directive or the Maritime Spatial Planning, for example. For our contractors, of course, this has allowed for them to fund and develop their new services, and it gave them the visibility at the European level. So we've also been able to launch dedicated marketing campaigns. So here is an example of a dedicated marketing campaigns we launched for the H2020 projects. So there was articles and many social media posts which were promoting for the use of the Copernicus Marine Service data within H2020 project, using 3 examples of 3 H2020 projects, which were the EO for Wildlife project, the EO-NAV VOYOPT, and the Marine EO project. So those 3 are H2020 projects which are using the data. But there are many, many more H2020 projects which are using the data or that could be using the data. So if you are such a project, actually, please let us know and we will provide you with visibility on our website and within our use cases page, for example. So, yeah. So we've also been able to launch a new visualization tool that you heard about this morning. You had a demonstration by Guillermo about that, and we are going to talk about it in the roundtable just after. So I'm going to go very quickly on this one, but it's a very useful tool, which is very successful, and we have very positive feedback actually from this MyOcean visualization tool. We've been launching the Blue Book actually in order to reach out to EU stakeholders, the European Commission and member states. So this Blue Book is available online. It's a report to inform all the European citizens, including policymakers, students and youth, on how the Copernicus Marine Service benefits society as a whole. So this is a really nice book. Please check it. It is online. We've been promoting it during various events at the European Parliament, for example. But this is still an up-to-date document, which is very nice to read and very informative, with providing with the benefits for society. We've also published a lot of use cases and what we call the use case books and the use case demos. So those use cases are showcasing data usage. So they are really demonstrating how many users have been using the data for the different market sector. And for example, all those use cases book, you can find them per market, per country, or per region. So here you have the example of the use case books per market. So if you are, for example, from the marine conservation and policy sector, you will be able to look at all the use case examples for your sector, but you have the same books by countries as well. So if you are a German citizen and would like to see what Copernicus Marine can do for your country, you can also check the German use case book and so on. Of course, we've also been publishing a lot of articles in order to provide you with up-to-date information. More specifically, each time there is a catalog release, we've been publishing articles really describing for beginners or for experts as well, the content of each of the catalog release. So this is available online. And of course, we've been showcasing our offer on Twitter as well and on social media. And Gretchen really talked very well about it this morning. We have now a new website, which is really showcasing better our offer with really up-to-date content. So please go through our website, and we expect that you will be able to find what you need much better than in the past. So thank you very much. I'm gonna end here. And now I'm gonna leave the floor to Ken Fujiwara from Umitron company, who is the CEO from the Umitron company working for the aquaculture sector in Japan. So Ken, the floor is yours.
Okay, thank you, Lawrence. Hi, everyone. My name is Ken. I'm a co-founder and CEO of Umitron. Let me share my screen. Yep. So I work in aquaculture sector, and today I'd like to talk about the data analytics and feeding optimization for aquaculture operations. So just quickly about Umitron, we are relatively new company, started in 2016, and our mission is to install sustainable aquaculture on Earth. And we are operating in Singapore and Tokyo, and our service is basically data analytics and feeding optimization for aquaculture operations. So picture below is the places we visited, and we more put focus on actually visiting farmers and asking problems from farmers to identify what is actual challenge for farmers facing in a daily operation, and bring that problem to our team to provide new service for aquaculture sectors. So first product we have been using, Copernicus Marine data, is we call Umitron Pulse. And as you can see, this is ocean data map for aqua farmers. and which provide data to global thanks to Copernicus marine data. And we provide temperature, dissolved oxygen, chlorophyll, salinity, wave height, and which is important parameters for farmers. And we basically provide this for free, and we charge $30 per month for historical and forecast. And now it's accessible from website and also provide Android and iPhone app. So value proposition here we provide to farmers is basically extract important data for aqua farmers and provide it so that they can access easily in a daily aquaculture operations. So after launching this service last year, we have been receiving good feedback from farmers, and I'd like to highlight one of the oyster farmer in Australia is using temperature data to make the decision which farm to harvest oyster. So temperature is related to the grading of oyster, and once they have a temperature data, they can have a more finer resolution of where is a good place to harvest to provide good quality of oyster at a certain point of time. And also we are getting good feedback from sea bream farmer in Japan, and they use temperature, dissolved oxygen, and salinity. And prior to such service, they have been using insight sensor and taking ocean data manually. So now they can access to app and web service and easily get ocean data, and they can use for the daily operation. So those ocean parameters have been very helpful for aqua farmers. But I like to highlight there's also another challenges farmers are facing in a daily aquaculture operations. And we have visited many places. We visited in Northern Europe, Mediterranean, and South America, and of course in the Southeast Asia region. And aqua farmers are facing three major challenges. One is the cost. So feeding cost for farmers is really big, and it's actually increasing. So managing feeding and optimize feeding cost is an important challenge for farmers. And of course, it's the farming operation is exposed to natural risks such as algal blooms, disease management, and environmental changes. And nowadays, the consumer is asking more traceabilities and certificate in the farming operation. So this is relatively new activities farmers has to adopt. So starting from ocean data, we now focusing on feeding challenges for farmers. This is because first, it's the biggest cost factor for farmers. It's in production cost, feeding cost shares almost 70% of total production cost. And also it's basically manual labor. It takes a lot of time for farmers to work on feeding. In Europe, some of farmers are very advanced. They are using automated operation, but especially in Southeast Asia region and Japan, there's many small to medium-sized farmers. So like farmers has to rely on manual work to do feeding. And also it's important from environmental perspective. Feeding is actually happening under the water. So it's really hard to decide what is the appropriate amount and appropriate timing to feed. And sometimes waste of feed goes to the sediment and changes the water quality. So we are now working on feeding challenges. And what we're providing as a service is this automatic feeder we call Umitron cell. And as you can see in the picture, there's a small pen. This is a typical fishing farm in Japan. And we install our automatic feeder on the center. And this white box is our product. And on the top, there's a tank. And on the bottom, there's a mechanism to dispense feed. And we are basically operating this auto feeder to optimize feeding. And how farmers use this auto feeder is basically they can access to auto feeder from their mobile phone and utilize the camera equipped on the auto feeder to monitor real-time fish behavior And also they can control feeding remotely and also check feeding history, and also they can accumulate the data. So this kind of feeding operation greatly helps farmers to reduce labor at the farm. But to optimize feeding, this environmental factors are also important. And this is where the Copernicus marine product play an important role. So factors influencing fish feeding is, for example, temperature is very important parameters. Basically, fish is cold blood animal. So if the temperature surrounding their environmental changes a lot, the appetite of fish changes, and also digestion speed is also changes. So temperature affect like all behavior of fish. And dissolved oxygen is similar, but also after eating feed, fish increases oxygen consumption. So we need to be careful. Dissolved oxygen doesn't decrease much after the feeding period. And also salinity, lighting condition, ocean colors are also important ocean parameters for feeding. So now to utilize such ocean parameter from Copernicus marine product, we are optimize feeding using two major data sources. One is from Umitron Pulse, which uses Copernicus marine product, and we collect ocean parameters in a real time. And also we analyze the fish behavior in real time coming from the Umitron cell using a video feed coming from the auto feeder, and combining those data together to decide right amount and right timing to feed, and basically providing analytics output to farmers to optimize their feeding operation. And we have been using this system about a month, about a year from last year, and gradually getting a good result from farmers. So this is a result from red sea bream farmers in Japan. And actually their feeding efficiency increased by 30%. And also we could accelerate the growth of fish by 4 months in a year. Basically, aquaculture operation has been operated in a manual way a lot. So this kind of automation and data analytics, there's a tremendous room for improvement from our experience. So overall, advantage of using Copernicus marine products, there's a lot, but let me highlight. For my company, global data set is great. We can have a data set even in Japan and also even in Southeast Asia. So we can provide data to aqua farmers. And also it has a machine-friendly interface. We can directly access from our server. And also I'd like to highlight user support, including maintenance and alert support is very good since we provide real-time data service. So it's really important to have a maintenance and alert support. And for end users, it's easy access to ocean data, and the forecast data is good for feeding and also good for risk mitigation. And long-term historical data, we have been also getting a feedback from farmers, and it's really good to monitor like long-term environmental changes for farmers. And there's a couple of need for improvement. As Lawrence highlighted, it's similar. We want to have a more longer forecast data if possible. If we have a 1 month forecast or 3 months forecast, farmers can have a more kind of easy way to decide the harvest period, so they can plan better the farming operations. And higher resolution for Asia Pacific region is something we want to have. And like some data we are using right now is not updated daily. So if it is more frequently updated, it's really good for us. So in summary, yes, so Umitron works on aquaculture technology in Asia Pacific, and Copernicus marine products are really helpful for us to optimize feeding for farmers. And I'd like to highlight we are now closely working with aqua farmers and looking for potential collaborations in any way, like joint project or research and development. So if you have any idea or any project you're working on, please don't hesitate to contact to my email address here. Okay, so I think that's my presentation.
Thank you very much, Ken. This was very interesting. So now I would like to give the floor to Nathaniel Bensoussan, who is an independent coastal oceanographer working with Joachim Garabou for the TMedNet project. And he's going to tell us about marine heat waves. So Nathaniel, the floor is yours.
Yes, thank you, Laurence, for the invitation, and nice being with you today. So I'm going to share my screen. Is it okay? Do you see the display?
Yes.
Yes, thank you. So indeed, thank you again for this opportunity to introduce our activity and use of CMEMS product to track and assess the impacts of marine heat waves in Mediterranean coastal ecosystems. So it's about a teamwork conducted over the past 15 years with Joachim Garabou, senior scientist at ICM around a common vision. We know that climate change is a global condition with local impacts, and our vision is having a fully operative and cost-effective MPA climate change sentinel observation network in Mediterranean coastal ecosystems, which are among the most dynamic and diverse on Earth. Our approach is a collaborative approach based on the building synergies between numerous MPAs and research institutions, working with harmonized protocols to fill knowledge gap and track changes, starting with coastal thermal regimes, as is illustrated to the right. So we are interested in monitoring the nearshore coastal area using autonomous data loggers that are set at standard depths to obtain high frequency every hour in situ records, allowing to catch the high frequency variability and to see the seasonal stratification as here. Through sustained observation efforts, we managed to obtain some very long in situ time series, which are quite unique. So from marine weather to marine climate. So as I said already, this network, TMedNet, has been key to foster international cooperation, and we are providing a series of collaborative tools to directly support and provide feedback to members. I must note here that we have started the process of data transfer and data sharing with IBISAR Physics. We are also developing platform data services, some of which include Copernicus Marine Service, SST products. I'm going to tell you more about this. So our mission over the past 15 years has been to foster pan-Mediterranean cooperation and support climate change monitoring for the building of a network, as you see on the map below, and to build a unified, unique database on high frequency in situ temperature. To the right, you see the progress made since the beginning of the initiative, both at the country level and at the global level. So today it's over 18 million high frequency temperature, which, just to give an idea, is equivalent to over 2,000 years of high frequency temperature records. So records are conducted directly by partners in the 7 Mediterranean countries, from Gibraltar to Turkey and North Adriatic to southern Tunisia and the Gulf of Cabes. And here you have a color code for the time series lengths, showing that there are already over 18 sites with over 10 years of records, the longest being 20. Maybe important to precise that most sites are MPAs, and that's really a collective work from this collaborative approach. So now let me introduce some of the projects we have developed on a TMedNet platform and which are dealing with Mediterranean marine heat waves. As we know, they have been more frequent and more intense, are a major source of perturbation for marine ecosystems with the driving of mass mortality events, which are one of the major impacts, and cascading effects through ecosystems and socioeconomic activities. So what I'm showing here is a Mediterranean marine heatwave tracker at 4 kilometers and near real time that was activated last summer to inform on the propagation and duration, here the colors are for duration, of this intense marine heatwave that propagated in September. Our end users are scientific community, MPA management bodies, local regional public authorities, and stakeholders. Also the general interested public, because it's important to raise awareness on these events. This slide rapidly to illustrate the fantastic opportunity that CMS SST provide to evaluate, assess marine heatwave trends or marine heatwave events of a broad spatial scale and climatic time scale in the Mediterranean Sea. Analysis reveal worrying results, showing, for instance, in the Northwestern Med and Adriatic, a more than threefold increase in marine heatwave days. So these have been become more frequent, also more intense, and triggering mass mortalities. So what about the nearshore and subsurface? By then, during the first unprecedented mass mortality events of 1999 and 2003, we really faced the scarcity of seawater temperature time series. Now we have an improved data framework, improved TMedNet and CMEMS data framework, from which we can conduct statistical analysis to validate the use of coastal SST for the nearshore area. It was done over 22 sites, multi-year time series. We have also improved framework for marine heatwave statistics using the method of Hope et al. 2016-2018 to provide different services. The first being this early warning services combining reprocessed and near real-time gas-corrected data from CMEMS, and that was activated in summer 2019 and then 2020. Other product type, I would like here to insist on the importance of combining and joint use of these CMEMS satellite products with in-situ observation is about understanding and increasing our scientific understanding of subsurface marine heat waves and their impacts, notably on mass mortality events in essential habitats. So advantages of using CMEMS are really the ease of use and quality data. Also, help desk and network of experts, which are really added value to select and retrieve the best possible product, to extend spatial and temporal analysis in order to make the most of the database. Things that need improvements for coastal observation and coastal products on biophysical properties has been largely discussed here yesterday. So I want to jump directly to TMedNet synergistic potentialities regarding the increase in the density of subsurface high-frequency observation for ecosystem, for essential climate, ocean, and ecosystem variables. And also regarding the high-frequency variability and for product validation and development as will be conducted in the Bioficus action. So to conclude, coastal in-situ observation have a central role for research, operational oceanography, and the society. Since that the TMedNet approach, collaborative, cost-effective, is a proof of concept of an efficient strategy to enhance observation and scientific understanding of climate change. So we are currently extending this approach to other climate-related biological indicators with the support of InterRegMed. And for the future, what we propose, provided there is sufficient support for the sustainability of observation, is to maintain and extend the network and capitalize this MED experience for other EU regional seas through sharing of lessons learned. This for building a science evidence-based climate change adaptation strategies. And I hope, have strong hopes that the international context will be a favorable one for the building of a network for climate change adaptation. Thank you for your attention.
Thank you very much, Nathaniel. This was really interesting again. I would like to remind you that if you would like to ask a question, you can go to the queue on a button which is at the bottom of your screen and ask any question. We are going to have a session at the end in order to answer all your questions. So please do start asking questions with this tool, and we will answer them later. So now I'm very happy to welcome Henrik Ramm-Schmidt, who is the Chief Business Officer from NauticAI, which is a Finnish company, and he's going to tell us about how he's using the Copernicus Marine Service products for the navigation sector. The floor is yours, Henrik. So we can't hear you, Henrik. Can you try to speak again? No, we have a problem with the sound. So we still can't hear you. So maybe.
How is it now?
Oh, it's very good now.
Okay, good.
Go ahead.
Thank you.
Thank you.
Apologies for that.
It's okay.
So I'll be jumping into my presentation. So my name is Henrik. I represent a Finnish company called NauticAI, and we are in the maritime or commercial maritime intelligent awareness business. So our mission always has been to connect ships and people with data and do this hopefully in as much real time as possible. And this helps in making it more efficient to operate your vessels when you know where they are and you know the conditions they are facing. So the problem we work with, as I guess everyone else also in this IT business, is to get data to the right people, and then also so that they can understand it. This is perhaps something that many IT companies fail to master these days. You have a lot of data, but how do you actually make it visible and usable? So the concept for us is simple. We try to reduce information friction inside our customer organizations. We work very close to our end customers. We usually try to solve their everyday problems because that then makes our solutions operational and something that our customers use every day. So our typical customer is a ship operator, and when we see how they use our platform, we normally see 10 to 20 people online all the time, all day. So these are operational tools. So how we do this in our company, we combine affordable IoT technology these days from many different platforms actually. We do something called cloud fusion of data, and then we visualize information, and this is what we call intelligent maritime awareness. And some of our clients show that this is something that really works. We work with I think we calculated that our customers currently operate a revenue of around 30 billion euros. So they are not any small players anymore. And then we are also cooperating with a number of known IoT platforms such as Drillet and Inmarsat. So our system is one platform with multiple products. We do something called Snapshot, which is a real-time awareness solution, sort of like your mini VTS or your very own marine traffic system for incident management. Then we have operational tools for chartering and operations, for planning your cargoes, and then our new BOQA tool, which is short for bridge operations quality assurance. So basically automated event tracking and automated monitoring of your assets. Then shortly about the BOQA concept. This is the key thing we are working on. So this is usually based on IoT technology. So there is an IoT device of some kind on a vessel. It pushes data to our cloud. We combine it in the cloud with, for example, weather data, which is a central piece in any marine operation. And then also various types of company-specific data points. Then we do automatic detection of external influence on the vessel, on internal factors based on sensor data. And then we can push information in SMS and email to our clients so that they have a better view of how their fleet is operating. There is, of course, also a visualization layer, so a web platform with analytics and connections to BI tools. And then, of course, as with all modern systems, the APIs are central, so you have to have machine-readable interfaces to your data. And how do we build this? Also taking into account then Copernicus. So currently we like to use AWS, although we are not affiliated with them or tied to them. We could use something else also. But AWS seems to be a good choice when operating globally. For weather data, that is the topic of today, we use information from Copernicus. That's a very good source. We also use information from our own Finnish Meteorological Institute and their Hirlan model. And then we utilize, like many other operators, also the GFS model from the States. This is then all taken together in our weather servers and our background services. And then basically the whole BOQA system that we operate is more or less serverless from beginning to end. So there are very little servers, very little idle server power, and then of course a database and APIs. And then looking at how this looks in practice, we fuse data from asset tracking with forecast data or nowcast data to produce graphs such as these that you can track your vessels against weather conditions. We also, of course, visualize information, which is typical for situational awareness. And then we also automatically analyze the vessel events based on various external event data points, such as the weather data, to detect something called, for example, nowcast or high wind and wave at vessel locations. The system also utilizes forecast data so that it can check the vessel's upcoming route and then alert the operators if the vessel is heading into heavy weather. So as you see here, weather is a very central part of marine operations, and visualizing and using that is key to success in operating fleets around the world. We always like to say that the key is easy access to everything, and then that means that you should have dashboard views, you should have combined views, you should not need to go to 7 different web platforms to find your data, but it should all be there in your pocket, in your phone, or in your pad, or wherever you happen to be. And it should be easily accessible, visualized, and nice to use with snappy functions and showing you, let's say, the most important things that you are interested in your daily operations. So this is then, of course, a key to combine data from different sources, like you see here, live streaming, weather data, mapping, GIS information, ship sensor data, and so on. We also use observations. These are not coming from Copernicus, but we could add here that real-time observations are also a part. So we operate currently a free-to-use system for the Baltic area, which shows real-time weather data. And then we also integrate such information into our own snapshot platform. So this gives vessel operators even better view into the real conditions out there. In many cases, our customers actually have then also combined or connected their vessels' weather stations to the system, which means that in addition to the official meteorological observation points, our customers can also use their own vessels as observation points. We are currently two founders or two people in NauticAI, myself and Mr. Nuortia. I have a background as a captain on the merchant marine side, and my colleague Hiski, he comes from the telecom business side. And then our model is to work with various number of partners that we have gathered through the years, and these are sales and product partnerships. That's actually more or less it for a short presentation of what NauticAI is today. Then we see we have a few Q&A questions here.
Actually, sorry, Henrik, we are going to keep the Q&A for the end of the session and answer them later on. Thank you, Henrik, for this presentation. I'm now going to leave the floor to Matthias Delpey, who is in charge of research and innovation activities at the Sea and Water Environment Division from the SUEZ group. And Matthias is going to tell us about marine litter. So the floor is yours. And again, please, to all the participants, please ask questions through the Q&A button, and we will try to answer some of them at least at the end of the session. Thank you.
Thank you, Laurence, and thank you very much for having me doing this presentation today. I'm happy to tell you about the FML-TRACK User Uptake project. So FML-TRACK is the acronym for floating marine litter tracking. So the service we demonstrated as part of this user uptake is an operational service to support the reduction of floating marine litter in the coastal area. So the project was conducted by a consortium composed of the Center Reyes Protect from SUEZ, which is part of the Sea and Water Environment division of SUEZ. The Foundation ST, which is a research center based in Pattaya in Spain, and the company Telespacio France, which is an expert in space-related services and geoinformation especially. And so the consortium worked together developing tools to support the management of floating marine litter in the coastal area, and more specifically, decision aid services based on different monitoring and modeling technologies, aiming first at improving the knowledge about floating marine litter in the coastal area, and then supporting different remediation strategies from reduction at the source up to interception in the coastal area and on beaches. And end users that are targeted by the service are mainly public administrations, who are in charge of managing the floating marine litter and in charge of cleaning of coastal regions, but also waste services companies for purposes of waste collection optimization, as well as scientific and associative communities more related to the knowledge improvement and knowledge and data generation about floating marine litter that is provided by the service. And so we developed and demonstrated this service in the southeastern Bay of Biscay, the transporter, French-Spain transporter coastal area there. And this demonstration was in the continuity of a previous live project, which was called Life Lemma, and which was further continued and developed as part of the Copernicus User Uptake FML-TRACK. So the service, the idea of the service and of the solution is to combine different innovative technologies to support the management of coastal litter, of marine litter and coastal litter, and to improve the knowledge about this pollution, which has many negative impacts on the environment as well as on the economy. And for that, different technological components were combined, gathering video and space monitoring, numerical modeling, and all these technologies being gathered in a decision aid system, aiming at supporting decisions by public administration, especially in a pragmatic and practical context. So the solution developed largely use CMEMS products. Different products are used. First, modeling products, which are used, so the regional models, hindcast, reanalyze, and forecast produced by Copernicus Marine Service, are used as current forcing at the regional level of our model, and also as a boundary condition for downscaling model, which refines the numerical solutions near the coastline. And we also widely used observations, in situ observations and satellite data gathered by the Copernicus service as part of the control and the forcing also of the different modeling components or of the different monitoring tools. And both real-time and forecast data are used, and delayed system and reanalysis as well, because as you will see, the service is deployed both in a kind of hindcast reanalysis mode and as well as in a forecasting operational mode. So here is a composition of the different technologies involved in the service. And so the idea is that, at least the approach that we followed as part of FML-TRACK consisted in saying that, okay, there is different technologies that could generate information about floating marine litter, but the issue being quite complex and the coastal area being a very dynamic area, only one of these technological components alone cannot fully answer to the question and to most of the questions that we have about floating marine litter. So the idea here is to have an integrated approach which will gather different technological components and to try to take benefits of each of the information that it can bring. And so we explored the capacities of high-resolution satellite imagery to track floating marine litter accumulation in the coastal area. Then this was complemented by a monitoring technology, which is based on videometry. And so from high-resolution video station installed at river estuaries, technology was developed to estimate the floating litter flux from the river to the coastal area, to try to monitor this continuously and in real time. And then this information are connected to a numerical modeling system, so a model which is based on Knowcean modeling and which will compute the transport of floating marine litter in the surface ocean at different space-time scales. And finally, all these informations are gathered and summarized into several decision aid indicators, which aims at supporting either decision making by the public administration or local authorities in implementing collect strategies or reduction strategies for marine litter, or also in an operational mode to support the day-to-day collect operation on beaches and at sea with the tracking of marine litter, which is provided by the system. So in this mode, the system is predicting hotspots of floating marine litter in the coastal area, and collect vessels are guided toward these specific areas in order to maximize the efficiency of the collect effort. And the service was demonstrated in realistic conditions in the study area during the summer 2020. It involved 4 collect vessels, so 2 fishing vessels, which are fishing crews who are collecting floating marine litter during part of the year, and then 2 dedicated cleaning vessels. It was complemented by beach cleaning, which also participated in the demonstration by city services. And in the area, we monitored the input of floating marine litter by 2 main rivers, the Ado River and the Oyo River. So we performed a 5 months demonstration of the system, during which the service supported the collect operation and gathered information about these operations. And then we assessed the efficiency of the tool, of the service, and it allowed to confirm with our end user the interest of having such information to support their strategies to fight against floating marine litter in their region. So the use of Copernicus products in this service was of great interest, especially the numerical modeling products, which allow surely to save time and money in implementing the service and focusing on the coastal area, which is our area of expertise. And then it supported the relevancy and the efficiency of the service for our end user. And the service helped these end users to optimize their day-to-day collect operations, and also to monitor this collect operations, so to transform this collect effort into a source of information, also to improve knowledge about floating marine litter at the coastal scale. So finally, there are some improvements that the project suggested about the Copernicus Marine Service data. A few are listed here, and most concerns the numerical modeling project, which are already of great help, but of course we are always seeking for additional information to be even more efficient. And so finally, our consortium, so composed of SUEZ, ASTI, and Telespacio, developed the FML-TRACK service to support the reduction of floating marine litter in the coastal areas by combining Copernicus Marine Service information with different monitoring and forecasting technologies, with the aim of supporting both day-to-day collect operations and longer-term remediation strategies. And currently, the service is under replication on other areas, and especially on the Med Sea areas in the Bay of Marseille region. That's it for me. Thank you.
Thank you very much, Matthias. Again, we are going to wait for the end of the session to answer all the questions, or some of the questions. I am now happy to introduce Emma Reyes from SOCIB. So she's the high frequency radar responsible at SOCIB in Spain. And she's going to tell us about the IBISAR project. So,
good afternoon.
The floor is yours.
Good afternoon, everyone. So thank you very much for this opportunity to introduce the IBISAR service. This is Emma on behalf of the entire IBISAR team. I will share the screen now. So hopefully you can see my screen now. If not, please let me know it.
It's okay.
Thank you. So as I said, I would like to introduce you the IBISAR downstream service for real-time data ranking in the Iberian Biscay Island regional seas for emergency and search and rescue operators. IBISAR has been improved, validated, and promoted in the context of a public-private partnership of intermediate users. As a project coordinator, we have SOCIB, marine research infrastructure and data provider from the public sector, RPS, Ocean Science, which is a downstream consulting company from the private sector, and ASTI Technalia, a technological center with expertise on marine research, which is a private non-profit organization, both playing the role of project partners. And it must also highlight the active collaboration of the Spanish Search and Rescue Agency and the Spanish port system in this project. As everybody knows, the effective response to emergencies needs reliable and current predictions and observations. SAR operators and emergency responders need therefore to evaluate the performance of different ocean prediction available in near real time. As highlighted yesterday during the product quality working group presentation, users want to be able to have confidence in the data, and they want to know how good are the data and which datasets should they select to run their applications. So addressing the user concerns, IBISAR Skill Assessment Service allows the visualization, comparison, and evaluation of the model performance in the Iberia-Biscay-Ireland regional seas. IBISAR helps the users to identify the most accurate ocean current dataset in a specific area and period of interest, thus facilitating decision-making to the search and rescue operator and emergency responders. The service is freely available under registration in ibisar.es. IBISAR has three main elements. The first one is the catalog, which collects, manages, stores, and serves a wide variety of data, including satellite track surface drifter from all the EB region, 6 HF radar networks also from the EB region, and 8 ocean models, 3 belonging to CMEMS, 2 from regional, and 3 coastal model downscale. The second element is the viewer, which is a graphical user interface to visualize the data and to make intercomparisons between models or models and observation at virtual locations specified by the user. And the third element is the skill assessment functionality, which calculates and displays the results of the model skill assessment by means of user-oriented metrics. And how does it work? So in just 3 steps, the first one is the service simulates trajectories using all available data sets. Second, IBISAR compares the pairs of observed and simulated drifter trajectory to assess the ocean model skills. And finally, IBISAR ranks the models based on their performance, considering the average skill score over the area and the period of interest as defined by the user. The benefits for the target users of using CMEMS data products by means of this kind of user-friendly services like IBISAR are to have a single access point of all in situ and model data, a regularly updated catalog, and customized access to the information with simplified metadata available in each layer of information and user-oriented metrics. IBISAR helps the user to improve search and rescue and pollution control operation by minimizing the response time, optimizing the search area planning, and allocating the resource effectively. The benefits for SOCIB as intermediate user are the provision of initial and boundary conditions from parent models for dynamical downscaling, the availability of satellite and near real-time observations for model assessment and improvement through data simulation, the funding for hiring staff and developing new downstream services, and the visibility of the developed downstream services and, of course, of the institution, and also the training workshop for identifying relevant products. It has been observed a lack of drifters in coastal areas that could consequently reduce the potential of the downstream service IBISAR. So thus, in this case, drifters data ingestion from complementary databases should be promoted, particularly those at the coastal areas. The refining of the geospatial bounding box and the position on land quality control tests, as well as the addition of some metadata, could be also recommended in the case of drifters. Concerning HF radars, the generation and the near real-time distribution of scientific added value products are required, such as, for example, the distribution of standardized gap fill data that could help to unlock its potential for the use in many Lagrangian applications, or for the development of the HF radar-derived short-term predictions. In fact, it must be highlighted that the US Coast Guard have been reduced by a factor of 3 in comparison with the HiCom model after 96 hours of simulation by using native radar-derived short-term predictions. And of course, a higher native radar data integration into CMEMS and further data uptake should also be promoted. Concerning models, the use of native radar data in particular and the CMEMS in situ data in general for data simulation and model assessment should be also boosted. The integration of user-oriented skill metrics and user-friendly assessment tools are recommended. And general comments are fully aligned and converge with the main finding from the Copernicus Marine Service Assessment questionnaire, as Lorenz pointed out just at the beginning of this session. As intermediate users, we are also requesting to have additional and updated products, so more coastal data, particularly drifters, added value products whenever possible, and to ease the data access, the visualization, the searching, and the download. An additional lesson learned could be the need to engage the private sector and to keep promoting the applicability, the usage, and the uptake to unlock the huge CMEMS data potential. We can conclude that SOCIB, as CMEMS intermediate user, benefits from the CMEMS data available for model downscaling, assessment, and data simulation, as well as for downstream services development. The Search and Rescue Agency in Spain, as a CMEMS end user, need reliable data, skill assessment tools, which provide user-oriented metrics, and it's also highly recommended to engage end users over the entire life cycle of the service. IBISAR, as a CMEMS downstream service, complement the decision support tools by providing guidance to the users to select the best available data product as input for the search and rescue and environmental risk modeling applications. And concerning next challenges for the Copernicus 21-27 as a user policy driving program, I think it might consider the evolving user needs, the allocation of a specific budget for progressing user uptake application, and the sustainability and continuity of existing services in the long term. So finally, I would like to take the advantage of this event to thank all the partners and collaborators, particularly our end users along the IBISAR project, also to Mercator International, and particularly the Client Innovation team for the valuable support along the project, and the marketing and communication for always being able to help us to improve and promote the service visibility. In case you are interested to know more about the service, so we will be more than happy to welcome you and receive your feedback during the interactive session of the IBISAR booth today, or through the QA session. Thank you very much.
Thank you very much, Emma. Indeed, we are going to be able to see the booth during the break, but just after the last presentation. So I'm very happy to introduce you with Renaud Laborbe, who is Directeur de Projet, Project Director at Artelia Digital Solution. And he's going to tell us about a new project which is called Wax Coast. So the floor is yours, Renaud.
Thank you very much, Laurence. So my name is Renaud Laborbe, and I'm very pleased today to present you the user uptake project Wax Coast, which stands for Wave Extreme Value Analysis at the Coast. I am working for Artelia in the Artelia Digital Solution department, and Artelia is a leading engineering player in Europe with more than 6,000 people. Turnover of more than 600 million euros. We are present in more than 40 countries in the world and operate in 9 markets, from building construction up to urban development. but today the maritime department is of interest. So, wax coast provides marine extreme value analysis at the coast. It has been developed in the Mediterranean Sea. And, the idea comes from the observation that human activity are constantly increasing at the coast, along the coast, with a number of infrastructure and nearshore operation in steady growth. So, however, with the emergence of new activity, not all the business models are compatible with the high-end consultancy services to estimate extreme extreme return periods. So they want to get the characteristic of the storm in the area. So for those newcomers, I would say, we have identified a need for a quick and accessible service that will provide extreme value estimate nearshore. So we will focus on two end users. On the right-hand side, we have the parametric insurance. Parametric insurance is income protection solutions against climatic hazards. It can be applied on expensive assets, but it's affordable products, similar to a home insurance. The price of you pay every month, it's not directly linked to if your home is damaged, the price you will receive. And an example of a parametric insurance would be that if for some regions the wave of the decade hits a shore, they will activate the protection. So those products, they need to have a quick and robust estimate of the wave of the decade. On the other side, we have the marine work contractor sector, mainly thinking of dredging and nearshore construction. And in this case, the bidding team or the sales team, they need to know how the storm will delay their work, how the nearshore data will have an impact on the project condition, but they will not work under a storm or anything like this. So we have defined a product with an on-demand business model with a fixed price per location. How does it work? So let's suppose you have an interest offshore the TMedNet harbor. It's a famous harbor, industrial harbor in the Strait of Gibraltar. So you just connect, click on the area. So here we have an example. We click just offshore the harbor. And we have set up a complete workflow that will propagate the wave condition provided by the CMEMS hindcast database near shore using a state-of-the-art numerical simulation. So we will first create automated grid generation. You see it as the blue grid on the picture on the right-hand side. And we will automatically generate the boundary condition and the forcing fields all over the period of the numerical simulation. And then the wave rotary wave propagation model will run automatically. We are using this wave model because we know it and it's very famous. Once the propagation has been performed over the complete period, we have an in-house algorithm for extreme value analysis that will provide the user with the 10-year return period estimate. And as you can see on the right-hand side, the user can have access to the estimate, 1 year, 5 years, 10 years return period, but also the fit of the low use, the fit, and how the storms look like, the direction of each storm, for example. If possible, there is a way to compare in situ measurement with the numerical simulation. When I say it's possible, it means if there is an in situ campaign available based on the data available from the CMEMS products, we can compare and get a score of the quality of the simulation. So for my end user, we have developed a very accessible product. It is online, automated, with a fixed price. So you know in advance how much it will cost, and which will get data where there is a need. It is reliable. The data behind are from CMEMS. The model used is the state of the art. When it's possible, we can perform quality control by comparing the numerical simulation with the campaign in situ measurement. It's very transparent, the methodology, and we have consistent methodology, meaning if you try our product offshore TMedNet in our example and offshore Marseille, you will be able to compare both results, given that exactly the same methodology has been applied. And for our end user, we have developed a very simple product. It's less than 5 clicks, you get your answer. Yes, it takes time, even on our Linux cluster. All this process takes time, up to 48 hours. But when the results are ready, you will receive an email and you will be able to connect and get, in the email, you will have a link to your results. So it's very simple. And for my company, I've been using Siemens product for many years now. It's very convenient. It provides a comprehensive oceanographic data catalog worldwide. It's reliable. We know all the work which is behind, and always have access to the data. It's quite consistent. And thank you to making this product always with continuous improvement. It's very good because the more products and data you have, the more I can integrate it to my product and make a better product for my clients. For the improvements, mainly technical here, for our specific wax cost product, it could be useful to have access to wave spectra directly from the CMEMS database. We have to reconstruct those spectra based on the mean parameters of different swells. If the wave spectra was already available, it would make our life easier. And we would like to have more statics file, the bathymetry of the model used. The bathymetry at each grid point could be very useful, for instance, to understand the results of the models. And regarding the in-situ measurement, we know there is a quality control, but it's very important because at the end of the day, it's, you compare numerical simulation with in-situ measurement. So it's very important to be able to rely on those data, and it will make things much easier if the file format was a little bit more consistent. However, we are very grateful for CMEMS. It has been able to create an ambitious product, wax cost. And for the future, yes, we need to improve our product because it was ambitious. So more improvements are needed regarding the automated grid generation, the wave model propagation, the current forcing, and so on. But it opens new market for us, insurance and marine work contractors, which are not our actual clients of our online tool. So it's very good. And no matter what, this work we have done will improve our data quality of our catalog, enabling an automated downscaling to bring the offshore condition near shore. And it has been mentioned today, it is really where the data are needed. And it opens new future for us that we know that it is possible to perform an automated numerical simulation on demand. So we have done it on a very specific case, but with time and work, we will be able to make this a wider product. So thank you very much. Feel free to ask questions on the question and Q&A button, and also to visit the booth afterward if we would like to have an online demonstration of wax cost. Thank you.
Thank you very much, Renaud. So indeed, I mean, we are running a bit out of time, but we have time for a few questions, and I would like to come back to you, Matthias, actually, Matthias Delpey. I have two questions for you. Are the algorithms that you've been using to detect the marine litter in ocean color, are they published?
Not yet, actually, because it is quite experimental. So we perform a series of tests with more or less successful results. And as part of the project, so one of the main conclusions that there is still some significant work to do on this part. And so for now, it is not published, but maybe once it will be fully validated, it's a possibility. Yeah.
Okay, and another question about the wave spectra. Are you using them for the boundary condition of the nearshore model, or do you have some other use for the spectra?
Yeah, the main use would be to use it as a boundary condition for the coastal and nearshore models, because so far we are trying to reconstruct this this spectral forcing from the different bulk partitions that are provided in the CMEMS product. But the full spectral information would be of great help to spend some time and gain accuracy in prescribing this forcing. Yeah.
Okay, thank you very much. Now we have questions for Nathaniel Bensoussan from TMedNet, who told us about marine heat waves. So we have questions and we are wondering whether the in situ time series you are collecting, whether they are injected back into the TMedNet and the in situ semantic assembly center from the Copernicus Marine Service. Is that data that is being put back into the system afterward?
Yes, it's absolutely the objective. So again, about the context, we are a small coordination team with absence of recurrent funding. But though we have engaged the process with TMedNet Physics, and we have an agreement to release more and more data over the 2 coming years, and also for yearly update, because we are in a delay mode.
Okay, thank you very much. Very interesting. And another question for you. How much is marine heat wave a coupled atmosphere-ocean process? And what are the leading atmospheric contribution to marine heat waves? Very large topic, but you have a few seconds to answer.
Okay. So definitely they are connected, all the more than for now we have been watching sea surface temperature and so surface marine heat waves. So regional marine heat waves like the 2003 for the Western Med, the 2010 for the Eastern Med are the leading drivers and processes. But what is still an open field for research is the depth propagation of this surface warm pool and subsurface marine heat waves. And for this, it might be more complicated than simple. There are also vertical transfer or horizontal advection. Hope I have answered, but I'm available and you can reach on my mail if you want to, if the person wants to have a further discussion.
Okay, thank you very much, Nathaniel. Now we have also a question for Ken Fujiwara from Umitron in Japan, who told us about aquaculture. So you said you are using dissolved oxygen data from the Copernicus Marine Service, and we have a question wondering what kind of resolution do you need for such dissolved oxygen data?
Sure. So ideally, if we have 1 kilometer resolution, that's very great. But dissolved oxygen is something related to local phenomena. So we see the challenge here to observe more, like get more data from a local observation and integrate into the kind of model to predict such data.
Okay, thank you, Ken. And last question for you. So algal bloom are indeed considered as risk for aqua farmers. Is that something that you provide within your service, information about algae blooms?
So for now, we are providing just chlorophyll data, and that is also related to algal blooms. But to identify if it's harmful or not, we need a more like a, kind of approach, different approach. And what we are testing right now is we are testing multi-spectrum observation using drone or aerial photos to have a more kind of finer spectrum resolution to capture such plankton's profiles.
Okay, thank you. Now, last question, and I'm sorry about that. I'm not going to be able to ask question to everyone. But last question to Enrique from NauticAI. There is a question on to whether you integrate or connected in any way to the marine traffic service.
Yes, as mentioned there in my reply, we have used them, yes, but we are not affiliated with them. We can use marine traffic data in our services, but currently we are sourcing our AIS information from other sources.
Okay, thank you very much, Enrique, and thank you very much to all the speakers. I mean, this was very interesting to hear about how all of you are using our data. We have very, very different application, and this is really great to hear how much the data we provide is useful for your application and for your business. So now we are going to have a round table. And I'm very happy to invite my colleague, Yann Drillet, who is the head of the operational oceanography, who is going to moderate this roundtable with me. So hello, Yann.
Hello, everyone.
So this roundtable is really going to be a dialogue between some data providers of the Copernicus Marine Service and some of the users of this data. So we have been choosing really 3 iconic products, which are the European North Wales Shelf Monitoring and Forecasting Center models. So we are going to have a user. So Matthias Delpey is going to be the user of this North Wales Shelf product. We also have Guillermo Grau from Lobelia Earth, who is a provider of the MyOcean viewer. He's been doing a demonstration of the viewer this morning. And we also have a user of this viewing tool who is with us today. And we are very happy to welcome Pascal Derycke from the Marine Analyst. And last but not least, we also have Anna Conchon with us, who is the data provider, the Copernicus Marine data provider of the Micronecton product, which is quite a new product in the catalog. And Sergi Perez Jorge, who is from the University of the Azores, who is a user of this Micronecton product. So I think I didn't introduce Marina Tonani, sorry about that. So Marina is the leader of the European North Wales Shelf Monitoring and Forecasting Center in the UK. And this is it. So Yann, maybe I'll let you ask questions to the data providers, and maybe then the users can dialogue with the data providers. So Yann, the floor is yours.
Thank you, Laurence, for this introduction. I think you introduced everybody from this round table. So we'll start with this question of resolution of the model. And so I start to ask Marina from the North Wales Shelf Monitoring and Forecasting Center. You have developed a new version of the North Wales Shelf system with a high resolution capability. So Marina, can you please tell us more about how temporal and spatial resolution have increased during this last period of CMEMS, and what's the impact in terms of resolution for the product and in terms of quality, perhaps, and then we can have discussion with the users of this kind of product. And I think that Marina has some issue with the Wi-Fi, so she can switch off the camera if it is better.
So afternoon to everyone. Thank you, Jan. I hope you can hear me well.
Perfect.
Unfortunately, my area is now affected by issues with the Wi-Fi. It's not just mine, so there is not much that I can do. But so I will go directly into the conversation about the improvements that the Norway Shelf has done since the beginning of Copernicus. In terms of resolution, we started with all our systems at 7-kilometer resolution, and we have since 2018, 2019 developed a high resolution system for ocean and wave at 1.5 kilometers, and this has been really a key development that it seems from the users has been very much appreciated. In terms of resolution, we deliver products as hourly as well as daily, but since the last release, the December release, we have increased the frequency of our data for sea surface height and the surface currents up to 15 minutes. And this is, I think, a really important update of our system, our capability. The quality as well of our system has constantly been improved, and this has been done via improvements in the initial condition for our forecasting system or for the reanalysis time series. And this has been done improving data assimilation. We started Copernicus with systems that were assimilating just SST, so sea surface temperature, while now we do assimilate vertical profiles of temperature, salinity, sea level anomaly, and very recently chlorophyll data. And this has been really a big impact on the quality of the products that we develop. And together with this, we have done several improvements to the model that have contributed themselves to the improvement of the forecast scales. And one of the last is the coupled version for the real-time forecast of ocean and wave that has represented a very good improvement, as you probably have seen in a presentation yesterday, in our capability to accurately predict currents. Also, the data assimilation of chlorophyll has been a step change in the quality of our products that should be remarked in this overview. And all our systems are continuously improved, and we continuously develop our system to be sure that we deliver to Copernicus the best possible product. And this is done thanks to all the feedbacks that we get from the users and their requests that are what are guiding us in the developments for our system. So I think that with this overview, I have just so provided some very general information about the improvement that we have done. And if you have any other question, please ask.
Thank you, Marina. And actually, we have a user of the Norway Shelf product, which is next to you. He's sitting next to you, basically, because when I see the two screens are next to each other. So Matthias Delpey from the SUEZ group, can you tell us about how you've been using the Norway Shelf products and what is needed next, actually, in the future? What kind of improvement you are waiting for?
Yes, thank you, Laurence, and hi again to you all. Indeed, we are using the NWS project. Here I will tell you about one of the applications that we made as part of a project called Marineo. It was funded by the Horizon 2020 Research and Innovation Program from the Europe, and it aims at supporting fish farms in managing threats related to storm waves, especially. And we developed a demonstrative application in one specific sub-region of Norway. which is called Rogaland, and for which we implemented a high resolution wave model, which is downscaling the wave solutions, wave product from the NWS area. And so downscaling the resolution up to the scale of a specific fjord, inside which there is many fish farms installed that are threats during the most extreme storm wave events. And so the objective was to improve here locally, to refine the wave forecast, and especially the extreme wave forecast in the area, and to provide the fish farms with some specific indicator about the threat in terms of damages to infrastructures and possible fish escapes and all these problems that may relate to the fish farm management. And so as part of this application, it was really empowered by the CMEMS project in the area. So especially the wave modeling product and the increased space and time resolution in these products. The model is also forced with some outputs from the physical modeling, the hydrodynamic model there, which are also used to force the model. And finally, we also used several Copernicus products, especially satellite products, for the purpose of model validation, and especially wave measurement from space and from altimetric data. And so for the future, so in addition to the continuity of this product availability, which of course for this application is really crucial, because it is one of the main inputs of the model and decision support tools that we developed. So in addition to the continuity, what we could need is a further improving in accuracy during the most extreme events. So what we obtain when comparing data with the observation is that it can happen that the most extreme wave events can be less well predicted by the wave model, especially where they're underestimated in some conditions. And so it is specifically a problem for this application with especially targets extreme events. And then it was already mentioned in my previous presentation, but availability of full spectral information as an output of the regional wave models could be of great help also to increase the accuracy of the local model, because it could allow to improve the boundary conditions that are used to force our local model, and allow us to also to simplify the link between the regional and the local model, and to have an increase in the efficiency of this downscaling procedure.
Okay. Thanks a lot, Matthias. Yes, I think you highlight a very important point concerning wave spectra and also extreme events. It should be something that we will take care for the following development in CMEMS. So I think we can move to the second topics, because we have not a lot of time. So Anna, concerning the micronecton, so you are at SUEZ developing the micronecton model, which is part of the Global Monitoring and Forecasting Center. So please, can you tell us about this model and what kind of product you can provide with this model of micronecton?
So thank you, Ian, for having me, and thank you for the question. So actually, it's a zooplankton micronecton model. So I think most of you know zooplankton. They are organisms drifting over the currents.
I think there is some problem of sound.
Can you hear?
Perhaps you can switch off your camera when you talk.
Okay. So is it better now?
Yes.
Maybe. Okay. So zooplankton are quite well known. So they are from 200 microns to 2 centimeters. Micronecton is a bit less known. They are organisms ranging from 2 to 20 centimeters. They are kind of able to swim on short distances. Small fish, small squids, and small crustaceans compose the micronecton. They have a central place in the trophic chain, being the predators of the plankton, and the prey of top predators, so they are a key part of the chain. One of their key characteristics is their ability to migrate from the surface during the night toward deeper layers of the ocean during the day. Concerning the product, it's issued from the low and mid trophic level component of CMEMS. CMEMS is a suite of models modeling the trophic chain from zooplankton to top predators, mainly tunas and tuna-like species. The development of CMEMS began in the mid-90s in Nouméa by the Oceanic Fisheries Program of the Secretariat of the Pacific Community, the SPC. It was funded under several European development projects. The goal was to propose a new management tool considering both the fishing impact and the environmental viability. Since 2006, in partnership with the SPC, its development has continued with the Marine Ecosystem Modeling Team of CLS. CLS aims to combine this modeling approach with satellite observation and real-time data collection to develop operational application and advise government administration on the sustainable management and monitoring of marine resources. So at first, the micronecton model was only a component developed to fit the tuna model, but now it's also a standalone model. And we have a product in the CMEMS website, a quarter of degree weekly product, but in a short time, we will have also a 12th of a degree daily product that will be available. And we are very excited about this one because the simulation are really interested. And also at the moment, we are participating in 3 Horizon 2020 projects and 1 Copernicus service evolution project to improve the model and its parameterization. So we are working a lot on this model. And if you have any question, we'll be happy to answer them. And you can have a look at the booth and see the little video, and you can answer any question if you have them.
Thank you very much, Anna. And actually, I'm going to leave the floor to Sergi Perez Jorge, who is a researcher in the University of Azores and who is the user of the micronecton product. So please, Sergi, can you tell us about how you've been using this micronecton product and what you would like to see next in terms of micronectons and similar products?
Thanks, Laurence. Yeah, our team, the Azores Whale Lab, have published recently a study that for the first time has been described in detail the spatial and temporal distribution of large baleen whales and their movements across the mid-North Atlantic Ocean. On this study, we combined telemetry data, like animals that we tag, from 3 different species of baleen whales, like fin whale, blue whale, and sei whale, combined with prey model from the micronecton Copernicus data to study their monthly distribution and also to identify the main habitats along their habitats. And we have also seen how they were moving, from mid-latitudes to northern latitudes for their feeding strategy. And also we have used this micronecton data combined with also acoustic data collected at different sea mounts that does allow us to identify different foraging strategies, not only for sperm whales, but also for dolphins. Both of these studies have been crucial also to implement appropriate management and conservation measures for cetaceans. And one thing that we have been in contact with CLS and we would like to see, we have mainly 3 things that we'd like to see on this micronecton product. First, an increase on the spatial and temporal resolution, especially important in areas such as the Azores region, where conditions are very dynamic and where, due to the abundant number of sea mounts that we have an irregular bathymetry. Currently, we are using weekly and daily resolution. Second, we would like also to see an increase on the vertical and depth resolution, because this will allow us to have a better understanding of the different layers that the different species of marine top predators are targeting. And finally, one thing that we'd like to see and think will be very useful will be to validate the micronecton and the zooplankton product also with in situ data from our region, because will be very useful. Thank you.
Okay, thanks a lot. I think yes, we will move to the last topic. So please, Guillermo from Lobelia, you presented this morning with a very nice demo these new tools available on CMEMS website, which is a MyOcean visualization tool. So please, can you explain how it works and how we can dive into CMEMS product with these tools? Thank you.
Well, thanks, Jan. Good afternoon, everyone. We think that at Lobelia, we think that a good viewer is one that don't notice. It's basically transparent. So if we have achieved this, then I'm happy to hear that. The first time you use it, you don't need to read a manual. For us, it's very successful if it's only a couple of minutes and you are already familiar with the application and maybe even discovered something about the data that you didn't know before. So we try to do something for CMEMS that's like that stays out of the way and showcases the value of this data without causing any friction. So when you enter for the first time, you see some data sets already waiting for you. Then if you click on a map, then you notice that you can do something with this data and you get relevant plots for that location. Then maybe you try out the plots and you drag something and you notice that you're taking to different times and depths. So the whole application is full of details that encourage you to try different things, discover and experiment with the data. Yeah, so it's been quite a lot of effort behind the scenes to make this simple and powerful at the same time. To be always available and support these 3,000 layers of CMEMS data that is really challenging to support and then be scalable and so on. And I think one of the important things we did from the very beginning is to listen to user feedback via Twitter and incorporate it while we were developing the application. Some users suggested to use CMOcean color maps, and even including a mode for colorblind users. And I think that pays off in the end because, for example, since September, we've had visits from over 2,000 cities from 140 countries around the world. So, and they are also spending a lot of time in the app. We've seen more than 300,000 events in the catalog, in the viewer, and in the share features. So we're really, really very happy with the results. And of course, we will keep listening to the users to see what they want.
Thank you very much, Guillermo. And indeed, this is a very successful tool. And I'm very happy to have Pascal Derycke here from the Marine Analyst, who is actually a user of the viewer and who can tell us about more why he likes this tool and what he would like to see next as an improvement for this tool. So Pascal, please go ahead.
Yeah, okay, I'm going to give a very short feedback on this beautiful tool. What I like is it's a map viewer. So you see big maps, beautiful maps, full of color. And when I think that the European Space Program is for the benefit of society, you see that we are professionals, but this tool is also dedicated to the general public. So you can easily use it for education purposes, academia. It's really beautiful. With our team at the Marine Analyst portal, what we thought we could build a marine protected area bulletin. So we used the MyOcean map viewer to just browse in it and to see what it is available. If you want to have marine protected area bulletin, you need near real-time products and forecast product. And when you go in the map viewer, MyOcean map viewer, what is very nice is the filter. So if I'm thinking I would like to have only global products from Marine Copernicus, there are so many products, so you don't want to lose all the day to find out what is available. So you select global, you say, okay, I want temperature, I want to have present, so near real-time products, I want to have satellite observation, and L4, that's for the professionals. And then you've got a full list, and it's done in few minutes, and we were able to select 30 products to build our MPA bulletin. So this service is dedicated to the park managers, and you are able to build an interface based on what we've discovered in this map viewer beautiful tool. Now I know that I've got a question about what next. Okay, it's all really tiny things. Like for instance, I think within the filtering options, resolution is important, the time and spatial resolution. I think also for the general public, it is important to understand what it is exactly. We are collecting images, we'll build an archive, but depending on the sensor resolution, we've got different type of products, and the time is important. Like for instance, what it is, I'm really speaking about the aspect of education, what it is a climatology, for instance, to be able to filter this. Also have metadata. I think it's important to speak about metadata and to explain what it is. I've noticed that you provide the XML file, and for instance, I would like to have a metadata reader, even if the link to the XML file is important, but the metadata reader, I think it will be something which will improve the access to the information. And also, this is a question, so when you click, you select an area, it's very powerful to have a time series. So you display graphs. I would like to know if it's possible to access the tabular data. So I imagine in schools, they will be able to extract the data and play with it. And the teachers, they will be able to analyze and say, hey, here you've got actually sea surface temperature anomalies. Here is, despite the climate change is colder, and here it's warmer, things like this. So just, is it possible to access the tabular data to play with it? So that was my feedback. But again, congratulations, it's a really nice tool.
Thank you very much, Pascal, and thank you to all the panelists and all the speakers from this afternoon session. So thank you, Marina, thank you, Anna, Matthias, Guillermo, Pascal again, Sergi, and Jan. It is really important for us to hear about the user feedback, so that our offer is user-driven. So I think this is very nice to have users such as you who are really committed to provide us with feedback. And I'm sure all the data and the service provider here that has been hearing your feedback are going to be working very hard in order to improve their product and services for the months to come. We are gonna break for an interactive session. So I'm gonna leave the floor to my colleague M.Tonani from Mercator Océan, who's gonna tell us about what's gonna happen and what you're gonna be able to do during this interactive session. But before giving you the floor, I would like to say that we are gonna resume at 5:30, so after this interactive break. So please come back at 5:30 for a roundtable, which is going to be led by Fabienne Jacques, who is a policy officer at the European Commission. And she's going to moderate a roundtable about the Copernicus Marine Service in support to EU policies with the European Commission perspective. But before breaking, Enme, I'll let you showcase what's going to happen next. Thank you to all the speakers.
Yes, thank you, Laurence. Hi, everyone. I would like to invite you to visit the user uptake booth in Hall C. For that, I will share my screen. This one. Okay, so when you visit the fair, you can go to the Hall C, the user uptake program. Here you will find 23 of the 40 services developed under the CMEMS User Uptake program. When you click on a booth, for instance this one, you can see on your left a short presentation of the service. By clicking on the orange label on the poster on the background or the info panel, you have a web page dedicated to the service with many information to see how the CMEMS products are used and useful. And you have on each page is a button to access to the service. You can, of course, contact people on the stand. The interactive session starts at 4 now, and do not hesitate to click on button here, for instance, the Zoom here, or on the chat button to ask your question. People present on the booth are here for you to answer all your questions. The chat and this link, video link, allow you to discuss as you would do during a poster session. So do not hesitate. And I would like also to thank all the user uptake contractors who are the booth during this interactive session. Thank you for your attention and enjoy the visit.
Thank you, everyone. So we are going to break for a 1.5 hour interactive session, and we'll see you back at 5:30 for a roundtable about the European directive perspective. Thank you. See you. Bye-bye.
Bye. Thank you.